recorded period 6 yesterday, so we're going ahead and starting off with these examples, and I'm going to go quickly because you guys have had some time to play. So now it's my turn to play. But am I playing with the easier one first or the harder one? Which one? Easier. All right, I'm going over here. Why is this one easier? Anybody know? A, they told you what the U was, but also, isn't the du kind of nice? You guys put negative sign dx, right? So dx is equal to du over negative sign of x. Why is this nice? Because when you go to plug in, besides the negative, what happens with your already present sign of x and your dx that's being plugged in now? Don't they just simplify away? What's the struggle? Why am I not allowed to put bounds in right now? As they were. Why aren't I allowed to put negative pi over 3 and 2 pi over 3? Because they are x's, and I need to be changing to u's. So I could go ahead, I should go ahead, if I'm just now in my beginning stages. I could go from x equals negative pi over 3 to 2 pi over 3, right? Or I can go from negative pi over 3 to 2 pi over 3. But I need to see a raise of hands. How many of you guys went to u bounds and you never looked back? Who went to u bounds and never looked back? Who stayed in x's the whole time besides your integral? Okay, just because of the proportion of hands, I'm going to go ahead and do what most of you did, aka you stayed with x's. Now, can I stay with x's in my integral and still solve it? No, I have to use my u substitution. So we're going to go ahead and keep going to u to the negative 1/2 du. X is within. Why do I have to keep writing this? Because what kind of integral was it from the very beginning? Definite. And so I need to keep it definite, and the only way to keep it definite is to have bounds, and if they're x's, I can't write them there because they're not used. We used our power rule, and hopefully you guys got 2u to the 1/2. How many of our brains actually think in u to the 1/2? None of ours. But did you guys rewrite it to make it easier on your brains? So it's going to be square root of u. Since you guys kept it with x bounds, I'm going to plug in who u is. Are we doing okay? And now we can bring back our negative pi over 3 to 2 pi over 3. Bless you. Are we good? Why did I go back to x's? Because what are my bounds? X bounds, right? Now, fundamental theorem of calculus, all I need to do is f of b minus f of a. So we have 2 times the square root of 2 plus cosine of 2 pi over 3. I'm just going to write it. We're going to get to the unit circle in a second. Minus 2 times the square root of 2 plus cosine of negative pi over 3. I'm going to go ahead and pull out my 2, just because it makes life a little bit easier. I have the square root of cosine of 2 pi over 3. Isn't that a negative 1/2, right? Cosine of negative pi over 3, isn't that a positive 1/2? And so let's go ahead and just go there. Isn't 2 4 over 2? So 4 over 2 minus 1/2 would be 3/2. Minus 2 plus 4 over 2 plus 1 over 2 would be 5/2. Do you think that's the answer that would be chilling in the multiple choice options? Nope. What can we do? What do you guys think about the following? What if I have negative 2 times root 3 minus root 5 all over root 2? Is that legal? Yeah, I can do square root of 3 over square root of 2, square root of 5 over square root of 2, common denominators all over root 2. Why is that helpful? Hey guys, isn't this 2 to the 1 and not 2 to the 1/2? What would 2 to the 1 and 2 to the 1/2 reduce to be? 2 to the 1/2. Guess what that could change to be? If I'm multiplying a root by a root, guess what? I'm going to go ahead and have negative root 6 plus root 10. Do the same thing as root 10 minus root pi. I'm going to catch up to you guys. Rachel Chen, you're doing what? Thank you. Go team. I would, but I was in Guatemala. Well, and they don't like my iron levels, but besides that. Okay, square root of 10 minus square root of 6. Dun, 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 dun. How are we doing? Questions?
Yeah. How come when you went from u to the negative 1/2, it's like the negative?
Sorry. I went ahead and did a quick little in-between step of 2 over 1 times u to the positive 1/2.
Oh.
I was just lazy and didn't want to have to write this. Sorry. So I did a lot of all at once. There you go. So I added my 1, I added 2 over 2, and then I multiplied by the reciprocal. So, any other places I went too quickly or I lost you? Okay. Can I go play with the hard one? Why did it need integration on track?
We write x as a step.
Yeah, you guys all did 9 minus x squared, right? But when we went to do dx, wasn't there some extra even after the substitution? So when you go to plug in x cubed all over square root of u times du all over negative 2x. It's good, it's right. Well, hold on. Definite integral. I'm going to go to u bounds this time, just number 1. But you other ones, see that I see you, literally. But also to show you other ones that we're doing the x bounds, how it could also be done. But anyway, besides that, for right now, it's a definite integral. I have to maintain that meaning by trying to sub. But when I sub, Thomas, what were you saying a little bit louder about what happens?
You still have an x after you cancel out the...
Yeah, and not just an x, but technically we still have an x squared. Oh, all right. We know what to do, right? If we have an x, come on back and say, okay, x, who are you? Except, did anybody realize we didn't actually have to get x alone? You didn't have to go doing plus or minus square roots, because who are we substituting for? X squared. Just get x squared alone. We're creative. We're not computers. We can go play around with stuff. We see an x squared, let's solve for an x squared and say, ha-ha. Then we go ahead to plug in, and we have negative 1/2. Well, actually, hold on. I said I was going to u bounds. So let's go to u bounds. What am I doing when I write u of 3 and u of 0? What am I setting up and getting ready for? U bounds, yeah. Where do I go to find my u bounds? U equals 9 minus x squared, so plug in 3. 9 minus 3 squared would be 0. And then 9 minus 0 squared would be 9. Is it a problem that I'm going from 9 to 0? No, I can still do FTC. It's awkward. Could we switch it and make it opposite? Yeah, maybe we will. But for right now, 0 has to go on top, 9 has to go on bottom, because they have to match up with the lower and upper bounds that were x's, just in terms of u. Are we okay? Why am I writing them? Because they are now u's, which match up with my du's. So I'm going to have 9 minus u, plugging in for x squared, all over square root of u du. Can I integrate as is? No. There is no division rule for integration.
You have to take out the negative 1/2.
What did Patricia catch me on? I crossed out the x's, but what did I not cross off? What should come in half? In half. In front? Good. Is it easy to make little baby mistakes? So easy. Gotta be careful, yeah? So maybe some of you, when you cross that out, maybe you need to be like, he's still there. Don't forget him. I don't know. But it's so easy to make little baby mistakes. But now we're having to deal with the division. How many of you guys in your brain, whether earlier or right now, are thinking of this guy being u to the negative 1/2 and you want to multiply? Is anybody thinking that? Okay. How many of you guys are thinking 9 minus u times 1 over square root of u distributed? How many of you guys are thinking, whatever, I just need to divide both of them by the denominator? Interesting. So what are the rest of you guys thinking? I don't know how else to think about it. No, I'm really curious. How else do you split up division? Do you have any other ways in your head? Hold on, I'm pausing just for a second, Because it's really important, because, yeah, I graded your test, except for I have a couple people still needing to take apart. But I saw that you guys, some of you were doing super illegal math when you saw something like, you were like, oh, hey, look, it's x cubed over 3, and it's x squared over 2, and it's, yes, you made the mistake. What were you doing if you did this? Horrible integration. Why? Is there a property that says, oh, yeah, just integrate everybody, however you find them? No, that's not a rule. What's the rule say we have to do? We have to distribute. There is no multiplication. Sure, take his integral. Sure, take his integral. We don't care. No. The property says the integral of f of x plus g of x. I can do that separately, but can I do multiplication separately? No. So wouldn't you have to distribute and get this to be x cubed plus x squared and then do power rule? Okay, so what about division? If you have the integral of 9 minus u all over square root of u, somehow we have to think about this. And how do you think about it? Well, I don't know. I didn't teach you Algebra 1, sadly. Used to be I did teach the kids Algebra 1, at least the ones that are usually in calculus, but not anymore. So I don't know. I would say do Hart method, but that doesn't make sense to you maybe. So what do? Well, you can say 9 minus u times u to the negative 1/2. Does this mean the same thing as that?
Yes.
Yeah. And then you have to distribute. That's one way. You could do 9 minus u times 1 over root u. Is that the same thing? Yeah. And then you could distribute. Or you could do 9 over root u minus u over root u, being like, oh yeah, I have to distribute the division. They both get it. I don't know how else to think about it. Does anybody else have another way? Okay, so look at these now. How many of you say, this one makes the most sense in my head? Just raise your hands. How many of you guys say, this one makes the most sense in my head? How many of you guys say, this one makes the most sense in my head? Okay, so let's just take this one out, and I'll never show that one. Does that sound good? But otherwise, guys, do you see how both of these are doing the exact same thing? Because what would I do for this? Wouldn't I rewrite this to be, for our purposes, 9u to the negative 1/2? Right? I would need to rewrite it. So it's the same thing. And then this one, wouldn't I need to rewrite it as u to the 1 minus 1/2? Wouldn't that be u to the 1/2? U to the 1 minus 1/2. So either way works. Either way, we end up with the next step to our problem. And the next step to our problem is negative 1/2, thanks Patricia, from 9 to 0 of 9u to the negative 1/2 minus u to the 1/2 du. Are we okay? If you don't like the 0 and 9, what can you do right now? Flip it and make this a positive. Is that okay? Okay, so I'm going to go ahead and flip it, make it a positive 1/2. Now, we're going to go from 0 to 9 because I flipped it. Let's do parentheses. I know, I'm sorry. I'm throwing a lot at you and it's going to make you really nervous about your test scores. I meant to get them in RunWeb and I didn't. I'm sorry. There's been a lot of stuff going on. Coming back. Bear with me. Bear with you. Coming back. With love. What do you need to do before plugging in 9 and 0 to this expression? Anti-derive. Your brain gets so caught up in the problem that some of you are like, oh, I know what to do, I know what to do. Plug in 9, yay, plug in 9, negative, nope, sorry, 9, u to the, okay, I'm doing a horrible job of showing this to you. But some of you are like, yay, I know what to do, I know what to do, I know what to do, I know what to do. What did you not do? You didn't anti-derive it. And I'm so proud of you for knowing f of b minus f of a. I really was on the test. But what do you have to do with an integral before you take away the integral? I know you know this. Just your brain gets overwhelmed, overloaded. I mean, even computers do, and they have so much more processing power than you. They're not very creative, but besides that. Okay? So how do we anti-derive? Add 1, yeah? Are we okay? And then divide by? And then minus, add 1, yeah? And then divide by, which is multiplied by the reciprocal. That 2 is going to pop up and be an 18 square root of u minus, I don't know, 2/3 u root u. Are we okay with that for our brains?
Can't you just make it 9?
Make it what, Thomas?
Make it 9 square root of u minus 1/3.
Oh yeah, you could pull out the 2. That makes it a lot nicer, right? So we could make that a 9, we could make that just a 1, and we could make that, well, that'd be 2 over, that's just a 1 too, right? So if we pull out the 2, that cancels out. Sweet, I like that. So we have 9 root 9 minus 1/3 9 root 9. That's f of b minus, wasn't that just 0 minus 0? Sweet. So then quick math. The 3's just cancel and we get 9, and then that would be 27. 27 minus 9. How many of you guys got 18? If so, you're right. How are we doing? Questions? Did you see the integration on crack? First of all, we needed to go back and solve for x squared. Did you see how I rewrote and then could not anti-derive until I split up? Did you see that I needed to anti-derive, needed to do f of b minus f of a? How much math is in this problem? Whew, a lot. But is it a great AP one? Lovely one. 'Tis lovely. There's a song in My Fair Lady about that. Anyway, are we done?